Okay, let we start before wasting our time. Let me share my screen. Wait. Before that, before we start, maybe I can ask some question. Oh, there is another one person last coming in. Saya nak tanya apa Nur Fazliana.
Yes.
Okay. For your your overview, maybe before you go to the class, you already done several revision. So, may I know what is the equation for lower bound for sign number?
Lower bound.
Yes.
To the power of n minus 1. This is upper bound. Let's lower bound. Lower bound equal to 0.
For sign number.
Sign numbers. To the power of n minus 1 minus 1.
Okay, thank you. Who's next? Muhammad Alif. Turn on your webcam, okay? Muhammad Alif. Okay. What is lower bound for unsigned number?
0.
Okay, thank you. So please enable your webcam, including Nur Fazliana. So today we're going to look into and learn on the range. Normally we just call it as a range, but yeah, throughout it is like there is a like upper bound and also lower bound, which is also we call together as a range. Now let's we proceed. Again, if you have any question, you can just stop me. Okay, what will be covered and what we're going to look into until we finish our module 2. We need to look into unsigned number, signed number, additional and subtraction. If you still remember what I told you yesterday, why we need to learn on like second complement, first complement, why we just cannot apply the unsigned and signed number and then we just adding, because there is something that error and so on. So I will show you later on why we need to learn other method or approaches. Before we go deeper, we need to learn on unsigned and signed number. For our normal, this one is to see, right? Yeah. For our normal numbering system, our integer, which is decimal, of course, if we just write down like this, we know, okay, this is 9. And supposedly, if there is nothing in front, we assume it as positive number. So that's why we didn't put any symbols in front, because we already like familiar. If there is nothing, it is supposedly positive, or it can be also as unsigned number. And for all the positive number, rarely we put the sign. But if let's say it is a negative number, we need to put a sign in front to just make sure that we know, oh, this is negative. And when we play around with the symbol, it will be included in the sign number. Although you just put, let's say, negative, positive 3, still it is a sign number because we put the sign. And unsigned number, no need we like had it to things because it is no negative value, and it is our day-to-day numbering system that we apply, so it's really easy for us to understand. And the number will be started from 0. That's why Alif mentions that our lower bound for unsigned number will be 0. It will be fixed to unsigned number. Our lower bound will be 0. And the maximum or the upper bound is depend on our number bits. So if let's say there is no bit mentions, it is also can be called as infinity. From 0 to infinity, this is our range for unsigned number. But when you will be given with the bits, of course there is a maximum to this. So you need to know the equation for the lower bound and also upper bound. And when you get this lower bound and upper bound, it called as a range. Okay, now let's take a look into unsigned integer. You can see there is a 0 until infinity, and bits. Yesterday we already looked into bit by nibbles words. A bit can store unsigned integer from 0 to 1. This is when we are applying binary, of course. A byte of 8 bits can store unsigned integer from 0 to 255. Byte is 1. Uh, that's why to the power of 1, this is 1, okay? So that's why you have 0 and 1. You have 2. And when you have bits, when you have 8 bits, you're going to have to the power of 8, and all together you have 2, 5, 6 numbers including 0. This one, 2 numbers including 0. 1, 2. And the range for the upper bound will be to the power of n minus 1. This is n if let's say we have bits which is 1. This will be 1, then we will get 2 minus 1 equal to 1. This is our upper bound. And as mentioned, for our unsigned, our lower bound will be 0. So if let's say we have 3 bits, 3 bits, what will happen will be our lower bound will be always 0 as mentioned, and my upper bound will be to the power of n will be 3 minus 1. It equal to add minus 1, we get 7. So our range will be from 0 to 7. This is our lower bound, this is our upper bound. So similar to add bit, you're going to get 0 as a lower bound, and until up to the power of 8 minus 1 to the power of 8. is equal to 256 minus 1, you get 255. This is on your integer or nombor bulat. When you apply with binary, how you can get this maximum? How you can get this maximum? Let's say you have uh, 1 bit. So your maximum will be only 0 and 1 number only, the possibilities. And if let's say, oops, you have 3 bits, you need to have only 3 place, isn't it? 3 place for you to put. So the possibilities number that you can have 0, 0, 0, 0, 0, 1, 0, 1, 0 until the last you can have the maximum is 1, 1, 0. This is the only place that you have, which is 3 bit, and this is equivalent to 7. That's why the minimum is 0 and the maximum is 7. If let's say you have 2 bits, what you can have only 2 place because you have 2 bit, right? You can have the possibility to have 0, 0 as the lower bound, and the maximum will be 1, 1. For 1, 1 is equivalent to 3. That's why your range will be 0 until 3. 3 is your upper bound, how you will get to power of 2 minus 1. 4 minus 1, you will get 3. And you can see over here also, let's say you have 8 bits. 8 bits, you're going to have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 possibilities, and first of all, you will put 0, 0, 0, 0, 0 as the lower bound. And then what is your possibilities you have? 0, 0, 0, 0, 0, 0, 0, 1. And how to delete? And you can see over here, if let's say you have the maximum will be this is a possibility, and then you can change 1, 0, and the maximum you will have is 1, 1, 1, 1, 1, isn't it? So this is the maximum number that you can have for 8 bits. If you convert this 1, 1, 1, 1 to be decimal, you will get this number. That's why you will have this equation, just because there is no any place that you can add whatever number in between or beside or in front, because you only have 8, and the maximum you can have for binary only 1, which is 0 and 1 only. So if you apply all place with 1, then the maximum you will get this value. So let's move to next, which is this one is similar. You can apply, like if let's say you have 16 bits, it's also equal. This is your upper bound and your range as well. If there is a 10 bits, of course you can also apply the same. Lower bound is 0 and your upper bound will be to the power of 10 minus 1. This one is 1024, I guess so. Minus 1, you will get, this is your upper bound. And this is your range. That's why your lower bound, if you look for unsigned number, it is always 0, and your upper bound will be equivalent to this equation. And this is your range from 0 to 15, from 0 to 255, and etc. I guess no need for me like to explain too deep because it's easy for you just to apply, but you need to remember. If you cannot remember also by, yeah, our normal and defaults range, you can see you only can apply 111, depend on how many bits you have, and then you just convert it into decimal, then you will get the value of the upper bound. If let's say you forgot about the equation, so you need to like put all with the one, then you convert to the decimal, that is your answer. That's this one. So now let's we move directly to sign number, then we can like fasten a bit. For sign number, of course we have two sign, which is positive and also negative sign. We can have the similar magnitude with whether positive or similar magnitude with the negative. And sign bit positive or negative position, for us to put a position for MSB, whether it is at the left or at the right. Positive number. Uh, I don't know whether you already learned or not. Okay. I think no. Okay. If you still remember, last module one, I always mention if you have zero for your gates, if you have zero for your gates, you will have like this. If let's say this is zero and this is one. Normally for one, we will assume is, if you still remember, on, high, true, whatever term I mentioned last time, okay? Whatever term that positive, then you will know it is as 1. Whatever term that negative, you will apply and look into at the 0, which is off, false, low, and so on. But this is for your gates. You cannot apply this into sign because it is vice versa. If you look for sign, you will notice that positive will be applied for 0 and 1 will be applied for negative. So it's vice versa. Last time, for if you go for the gates, right, you're going to have low for 0 and high for 1. And this is always like positive, this is always like negative, this is will be off, this will be on. But for numbers, let's say you have 1 1 and you supposedly to have 4 bits number. 1 1 equal to 3 in decimal, so you need to put 0 0 for 4 bits. But for sign number, you need to be very careful. At your MSB, you need to put your sign. Positive, you need to put 0. Negative, you need to put 1. If this number is 0 in front, you will assume it is as 3 positive. But when you have 1 0 1 1, this will be negative 3. Sometimes you might confuse. It is also equivalent to 8 to 11, isn't it? But in question, don't worry, it will inform you that this is sign number and that is like certain things that is going to be, this is magnitude, this is sign, and etc. So you will be given a hint. If let's say, of course, like maybe sometimes you really confused when you um, answer your test or also your final exam, don't hesitate to contact me or any lecturer that you comfortable with and ask them about the question, just to confirm, not ask the answer, but just to confirm, this is it, this is a sign number, is it the in front is a sign, or is it it is like supposedly to be magnitude here and this is sign. Just ask, because bertanya tak salah, and you will not been asked to pay. It is free for you to ask. It is depend whether your lecturer or the lecturer that you ask want to answer or not, isn't it? But for your side, if they answer you, they help you, it is good. But if they don't, you don't have nothing to worry. Just use your privilege to ask. So if let's say you like maybe it's quite confused for you, you just ask me, and you can also ask maybe you familiar or maybe you comfortable with others lecturer, then you can proceed to ask them. Okay, now that is about our positive and negative. You can see over here, let's say you have this value, and when you want to put positive, you're going to put 0 in front, and negative number, you need to put 1 in front. So then we can call it as a sign number. Let's we take a look into several examples. When we have 4, when we have 4 over here, change first the magnitude. The magnitude will be 100, and about the sign is 0. How about 12? We will have magnitude will be 8400, and for the sign we put 1 in front. This is sign, this is the magnitude of 12, this is the magnitude of 4, and this is sign for positive. Let's take a look into the answer. As again mentioned, they will inform you basically how many bits that you will have in the question. But this one is just for you to see, okay, you need to apply 1 and you need to apply 0. We didn't look into the bit for just example. So over here you can see, determine the binary number is positive or negative. You can see it's directly give you like this. Maybe because it's bold, so this is like a hint for you. 0 will be positive and the rest will be your magnitude. But in the question, in your test, in your final exam, it's not going to give you a ball and then there is a space and the number. Normally it will be directly combined together, that without any space, without any ball. But it give you a hint with the byte. How many byte that you have? How many bits, sorry, that you have? Okay, sign number representation, this one which is still in our sign and magnitude, simple representation. After this also you're going to look into the equation for you to calculate the range, lower bound and upper bound. And then you need to apply first complement and second complement for sign number only. For unsigned, there is no casting. Why? Because later on you will see, if you just using a sign magnitude representation, when you want to go for adding, subtracting, you will get error sometime. That's why you need these two techniques for adding and also subtracting. Later we will look, okay? So now let's take a look. For unsigned number, we have lower bound as 0 and our upper bound will be 2 and minus 1. But for sign and magnitude representation, our upper bound will be 2 and minus 1. And you have minus 1 also, like similar here. But you can see for unsigned, you only have an n here without minus 1. But when you apply for sign, you have minus 1 here. That is only the difference. So you have the equation for uh, lower bound, you need to put negative. Basically, it's similar. And for upper bound, there is no negative in front. And n is total bits that will be given in the equation. For example, here it gives you a positive. Let's say this is your magnitude. This is your magnitude. You have positive, you need to put 0. And then negative, you need to put 1. How about the range? You were given over here the integer bits of 4 bits. And you need to calculate the lower bound and upper bound. You will get negative 2 for minus 1 minus 1. 2 for minus 1 minus 1. What you will get is 2 the power of 3 minus 1, which is 8 minus 1 equal to 7. So your lower bound will be negative 7 and your upper bound will be 7. So your range will be negative 7, 7 positive. So don't forget, because you are in assigned numbers, that's why you need to put sign. So this is your answer for the range. Lower bound and upper bound. And when you apply, basically why you get this, as mentioned, if let's say you have 4 bits, what is possibilities that you will have? Let me show you, let's say 0, 0, 0, 0. Quite many. So please be patient, wait for me to finish. Okay, this is my, let's say, normally if you have 4 bits, another 3 will be your magnitude. This is your sign. This is your sign, this is your magnitude. Let me continue here. Magnitude, sign. This is the only possibilities if you have 4 bits, isn't it? So you will continue all together. If let's say in like the decimal, you can see from 0. Don't confuse, okay? This one is the flow that always that I show you before this, until 7, and then continue. This is 8 until 15. This is the flow that you have. But when you apply into sign, you need to look into magnitude here and sign here. You can see this magnitude equivalent to 0, and this sign will be positive. But of course, our 0 is like natural. We can positive and negative, but throughout it's going to be positive all. and you have 1 over here, and your sign is positive. You have value of 2 positive, 3 positive, 4 positive, 5 positive, 6 positive, 7 positive. And over here plus, you can see 0 negative, 1 negative, -2, -3, -4, -5, -6, -7. This is your value. This is your magnitude. This is your magnitude. This is your sign. That's why when you combine it together, you have -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4 until +7. This is your range. That's why you get this. So you, in terms of, let's say you did not understand why and how you get this equation, so you do it manually and check one by one. Then you know, oh, this is the range. Let's take a look in a proper table. This is positive. You can see this is a sign, this is a magnitude, this is sign, this is magnitude. And please take note that it is not showing you 1000 because it is just as similar as mentioned. Whether it is a positive, you can like, if you want to put over here, which is 000, as the binary over here, and you put negative, it's depend on you, but it's as mentioned, normally 0 will just assume to be a positive side, because we already have here. There is no just +0 and -0. So it is a natural over here, we put always at the positive side, and it's continuous. This is just a representation on the table. In question, there is no like asking you to draw the table, but it is just directly asking you the upper bound, lower bound, and then the range. This is the table. The purpose of this table showing here just to show you actually what is happened and why you can get this value for upper bound and lower bound. So similar over here, if you have a decimal, 25 negative, 25 for 8 bits. Let's say we calculate first 25, we will get 16 plus 8. 16 plus 8 is 24. This is 0, 1, 2, 3, 4. So if we have here, this is our 25. Correct me if I'm wrong, because I just chongak. And then I will get 11001 for my magnitude. But it is only 1, 2, 3, 4, 5. I need to have another 3 space in front, because it's already mentioned 8 bits. And I know that this is my positive number. I need to put 0, 0, 0. This one is still a magnitude. This is the only sign. And if, let's say, for my negative number, this is still my magnitude. That's why I need to put 0, 0, because if I put 1, 1 over here, it will affect my value or my magnitude, isn't it? And my only sign is in front at my SSB side, MSB side. So I put 1 over here. So improper and more beautiful rather than compared to mine. So you will get like this. And for negative, it is like this. Similar that what I shared just now. Now, okay, after we already learn on all the signed and unsigned, when we have binary adding for the signed number, let's say I have over here positive 7 plus with negative 5. We need to show first in term of, maybe we 4 bits, okay? In term of 7 over here, we supposedly to have 1, 1, 1, 0. This is my positive 7. I need to add with negative 5. Negative 5, I will get like 4, 1, 0. And my sign will be 1. Negative 5. Correct, right? And when I add 1 plus 1, this one yesterday I already show you. So no need for me to show you again. 1 plus 1, you will get sum as 0 and carry as 1. 1 plus 1, you will get 0 as a sum, because later on you will add with 0, right? Nothing happened. 0 as a sum, your carry will be 1. 1 plus 1, you will get 1, 0. Sum as a carry, sum as a 0, carry will be 1, and you plus another one with 1 over here. This one, 1 plus 1 plus 1 will be 1, 1. 1 as a sum, carry as a 1. Sum will be 1, carry will be 1. So 1 as a sum, carry will be a 1. Then 1 plus 1, you will get 0, 1. 0 as a sum, carry as a 1. You can see over here, then you will see your value. You will get negative value, and your magnitude also will be wrong. You can see over here, you will get like something like 4, and then maybe negative. That's why you cannot apply directly signed number adding for binary. This is the purpose why you need to learn first complement and second complement for sign, addition, and also subtraction. So over here, I don't want to read. You can read by yourself. Similar to this one, I don't want to read. We direct go to the first complement. First complement, you can see over here what is basically happen. You only apply this method for this method only for negative number. For the positive number, nothing happen, especially for your value. You just add 0 as a positive in front. Nothing happen. You no need for you to change any value in front, inside, but instead you just need to add 0 for a positive, because you just want to apply it to be a signed number, isn't it? But when you play around with your negative number, let's say you want to go for adding and subtracting, you need first to change to first complement. For first complement, what will happen is you're going to change the value to be if let's say it is 1, you change it to be, if it is 0, you change it to be 1. If it is 1, you change it to be 0. As simple as this. But before you apply, you need to change first. In the question, you will be given how many bits that you will have. So in this question, it gives you 7 bits. 1, 2, 3, 4, 5, 6. This is only 6. That's why you need to apply 1 in front uh, later on, as it is a uh, magnitudes of a sign of negative. But we cannot use the magnitude as before this. What we need to do is we need to add only 0 as to complete as to be a 7 bit. Then because of this is negative value, what we need to do is we need to do a first complement negative number. We change everything. 0 we change to 1. 0 we will change to 1. 1 we will change to 0. 0 to 1, 0 to 1, 1 to 0, and 0 to 1. Then we get the negative number using first complement. So I repeat again. For first complement, you just apply this method for positive number. Let's say you've been asked, please calculate 7 positive minus negative adding in terms of a signed binary number. Signed binary. That's why you need to convert to binary first. But because this is positive number, no need to for you to consider the first complement method. Instead, you just use the sign magnitude that we learned in our previous slide. Sign magnitude is 1, 1, 1. And then our sign will be 0. This is the only things that you will do for positive number. Similar to here, if you are given with 0, 1, 1, 1, 0, it's give you positive. Then you just apply here as a 0 in front to be positive number. Just stop until here for positive number. No need for you to continue to think about first complement. Then when you have negative number over here, you cannot apply and put magnitude, which is, let's say over here it's going to be 101 for 5, right? And then for magnitude you need to put 1. You cannot do anything like this, especially for first complement. What you need to do is, if let's say negative 5, you know that it is 101. As again in question it will mention to you. But if let's say it did not mention, it directly give you what, like 101. Maybe you can just directly change it to be 010. This is the theory for the first complement. But in question, it will always give you how many bits that you have. So let's say over here, it will give you 4 bits. Of course, if it is 4 bit, negative 5 will be 0101. This one is not a sign, not sign, but this is just for you to complete 4 bits. Later on, you apply the first complement. First complement will be 1010. Okay, is it okay for this one? Any question, or you want me to give another example? Okay or not?
Okay, another example.
Again, no need for you to have another example or need another example.
Need another example.
Okay. So if let's say, if let's say you have a negative 11, negative 11, the value of
It's 9
11,
hours.
the value of 11, it will be 1011. This is my value of 11, but I know that this is negative number. And negative number, I want to change using my first complement. Directly, if I want to apply this one, I will always direct change it. It will be 0010. If it mentioned 4 bit, you just do this. If it mentioned for you to have 5 bits, you will need to put 0 in front, so your first complement will be 1. If it is mentioned for you 6 bit, you put another 0 in front and your first complement will be 1. Because everything over here you will be changed like 0101. If it's 7 bit, it's going to be 0 over here in front, and your first complement will be 1. So this one, no need for you to do similar things with positive. This one which is sign, magnitude, sign, magnitude. Because the first complement for negative, only you need to change 0 to 1, 0 to 1, 1 to 0. So don't consider anything here to change to be value of 1 again. Because this is only for sign, magnitude, representation. If you look here, this is the name for the method. Sign, magnitude, representation. This is for sign, magnitude presentations 0 and 1, 0 and 1. But when you want to go for first complement, you no need for you to do sign, magnitude again for negative number only. Positive number, you need to apply sign, magnitude. You're not going to use this method for positive number. Again, for positive number, you still just use sign, magnitude. Although you want to like convert it to first complement, there is nothing happen. There is no just method for you to apply. You still use the sign, magnitude for positive number. But for negative number, you need to apply this first complement method, which is change 0 to 1. If let's say in this example, it's not mentioned 7 bits, you just change it to be 110110. This is your first complement number because you just change the value. But in this question, it just show you that this is 7 bit. That's why you need to calculate first 1, 2, 3, 4, 5, 6. Okay, you need to add another 0 in front just to complete it's to be 7 bit. You cannot put 1 because your magnitude or your value will be different. You just put 0. If it is 8 bit, you just put 0, 0 in front here. You will be 0, 0, 1, 0, 0, 1, 0, 0. So this is 8 bit. If it is 9 bit, you put 0 in front. And you apply first complement, you will just change it to be. So this is your first complement for negative number. Although this is your value, let's say whatever value over here, I don't know, assume this is like 20, let's say this is 20, 20 negative, but this 20, you just change it using a first complement method just to make sure, okay, this is negative value. Is it okay for now?
Yes, doktor.
Okay, Doctor.
Okay, so you can see over here, this is similar table as before this, which is your sign magnitude, but we will have slightly different, which is because we use the first complement. Before this, we use a sign and magnitude, isn't it? Now we have the first complement. Nothing happened and nothing different for positive side because we just change it to be magnitude, sign magnitude. It is similar. But when we go for a negative value, let we try to change. Negative 1, okay, 1. We will have, it give you 4 bit, okay? 1 will be 0, 0, 0, 1. This is 1, but we know it is negative. But we don't want to use a sign magnitude. Instead, we need to use this negative to be first complement. So we just change it to be 1, 1, 1, 0. Again, if we have 2, 4 bits, 0, 0, 1, 0. This is my 2 and I know there is a negative number using first complement. What will I'm going to do is I'm going to do it to be 1, 1, 0, 1. I just change the value of 0 to be 1, the value of 1 to be 0, the value of 0 to be 1, 0 to be 1. This is my first complement equivalent to negative 2 using the method of first complement. Next, I have minus 3. Minus 3, I have 3 will be 1, 1, 0. No, 0, 0. This is my 3 and I have negative. Because I have negative, I need to apply first complement to change my negative here using my first complement. It will be 1, 1, 0, 0. Next, I will do for positive 4. 4 will be 4. It will be like this and this is negative. Because it is negative, I will do the first complement method, which is change 1, 0, 1, 1 and etc. So you can see my answer is similar like this for first complement. If let's say 4 for positive, what will happen is you use the, although it is called as first complement, but the method is similar to sign magnitude. 4, right? 1, 0, 0, and then because it's 4, it's going to be 0 in front. And you know the value first is a sign. This is your magnitude. You apply the similar thing with the sign magnitude for first complement positive number. But for first complement negative number, you need to use the method of 0 to be 1, 1 to be 0. Try to do different number. Maybe you play around with 5 bits, 3 bits, and etc. Express the decimal number plus 25 and negative 25 similar to the previous example, but last time it is a sign magnitude. Now it is a first complement. For first complement, as I mentioned, positive, nothing happen. Basically, we will do similar things, which is 1, 1, 16, 8, 4. This one, right? This is 25. We have 8 bits. 1, 2, 3, 4, 5, 6, 7. Our 8 over here for our first complement positive number will be 0 because it is a positive. This is our sign, this is our magnitude. First complement still use the similar method for sign magnitude positive number. So this is our first complement positive number, which is 25 first complement. But when we have 25 for negative, first we will do the 25 in terms of 8 bit. This is at bit 25 and we put negative. Okay, because it's negative, I want to change the first complement. What method I need to apply to change the first complement? I need to apply 0 to 1, 1 to 0. So I just directly change 0, 1, 1, 0, 0, 1, 1, 1. This is my first complement. So let's take a look in a proper way. This one is positive. These similar things, you can see this is your sign, this is your magnitude. But this is also first complement. Why? Because first complement for positive numbers also similar to sign magnitude. But first complement for negative number, you need to do first. This is your 8 bit. I think this might be like confusing you. This is black color also just for you to complete the 8 bits. It will be 0, 0, 0 to complete 8 bit in front. After that, you can see because it's negative number, you need to apply first complement method, which is 0, 1, 1, 0. So you just change to 1 to 0, 0 to 1, and continue. This is your negative 25 first complement, positive 25 first complement. Again, positive is similar to sign magnitude, but for negative, you cannot apply this again. Okay, I proceed. This is not enough for you to have a correct answer when you apply the one that I give you example. If you want to add this binary number, you still get an error if you use first complement. Then you need to have another step, which is second complement. Second complement is continuous from first complement. So if your answer for your first complement is wrong, your answer for second complement will be also wrong. Because you can see the process is convert the first complement. So your first complement value need to be correct first. So that's why in our daily life, in our class, I always mention you need to strong your basic first. If your basic is wrong, so your next future is also wrong. Similar also with our daily life, current, which is our life now, we need to be correct and then your future will be good. I think so. And over here, you can see we need to convert first complement, and For second complement, it's very simple, very easy for you to remember. Just add 1. So let's see. Again, for your positive number, you just use similar. Nothing happen. You just apply the things that is sign and also magnitude. So no need to worry about a positive because you just apply sign, magnitude things. But when you have the negative number over here, what you need to do, first you need to convert to first complement. After that, you need to convert to second complement. Let's see how it's going to be. This is your number. Is it 7? Again, okay. You need to assume it to be 7. This one, as I mentioned, in question, it will inform you how many bits. For this question, 100100, we have 6 only. And because it's 7, we need to put 0. Why 0? Just to complete, it's to be 7. And you have negative. Negative, we change its first to be first complement because it is negative number. Using first complement, what we're going to do, we're going to change it to be 1010 things. This is my first complement. Then we apply second complement, just add 1. This is the thing. Just add 1, you get your answer to be second complement. 1 plus 1, you get 0 and carry 1. 1 plus 1, 0 and carry 1. 1, 1, 1, 0, 1. The rest is similar. So this is your second complement answer. Then this one you can like adding things. There is no error. Let's take a look. So over here you can see you have this value of 0. Why I mentioned you? Because this 0 just for you to complete it to be 7 bit. If let's say it's a 6 bit, no need for you to put 0 because it's 6 bit. But if 7 bit, you just put 0. If 8 bit, as I mentioned, you put another 0. If 9 bit, you put another 0. Just to complete it to be 9 bits. And then, because it's a negative, you use the first complement negative number. You convert every single thing, 0 to be 1, 1 to be 0. This is your first complement. And second complement, how do you get? The one that I mentioned, you will add 1, 0, 1, 1, 0, 1, 1, add with 1. And you will get, sorry, you will get, you will get 101110. This is the things. If you see directly like this, you will like clueless, but this is because you add 1. See, add 1. So for second complement, easy peasy. Okay, in terms of this, as mentioned, this one no need for you to worry because it's similar to sign magnitude. I also don't want to touch again because we already looked. And our first complement also similar. Why? Because the value is totally similar. No need for you to change anything. You can see nothing happened although it is first complement. Second complement. Now let's take a look into our second complement for our decimal things. It is 4 bits. First, we have 0001 and negative 001, which is negative 1. First, we convert it into first complement. We will convert it to be 0000. Right. We convert everything over here. It's to be 1 to be 0, 0 to be 1, and etc. So you're going to see like this. Is it correct? Yes. And then after that, your first complement, your second complement, it should be you need to add 1. Why is 1 everything over here? Supposedly you will add 1 and then you have 0, 0, 1. Let me check. Negative, first complement. I think this one is wrong. Supposedly you will get this is as your second complement. Later I check, okay? For second, you can see you have negative 0, 0, 1, 0. Because this is your because this is your 2, which is 2, and then negative, you directly change to be your first complement. You will get 1, 1, 0, 1. 1, 1, 0, 1, you add with 1, you will get 0. You will get 0 plus 1, 1, 1, 1. This is your second complement. And then you have 3 over here. We have 3, 1, 1, 0, 0. 0, 0, 1, 1, and then negative. We change it to be first complement first. We will get 1, 1, 0, 0. This is our first complement. Our second complement, we will add with 1. Then we will get 1, 0, 1, 1. So our answer will be 1, 1, 0, 1. And 4. Our 4, it will be 0. Okay, sorry. This is our 4 and this is negative. We change this to be first complement 1, 0, 1, 1. And our second complement will be add with 1, then 1, 0, 1, 1, 1. So this is our, where is it? This one. This is our second complement for 4. And 5, you can see similar also. You have 4, 0, 1, 0. Okay, this is our 5, and because this is negative, we will apply the first complement to be 0, 1, 0, 1. And we change this to be 1, 0, 1, 0. This is our first complement as a negative 5. And for second complement, we add with 1. That's why our second complement will be 1, 0, 1, 1. Because we add with 1. So this is second complement or equivalent to minus 1 second complement. And you can try until the rest, it should be similar. I don't know what happened here. Maybe this one is first complement. First complement also is not 0, 0, 0, 1. When you change to final first complement, you will get like this, supposedly. And
Madam,
yes,
isn't it get 1110?
1, 1.
10.
This one is first complement. And then you add, right? With 1. You will get 1, 0, 0, 1. So this one I need to check whether there is a correction or not. Okay, 7 over here, there is an example. Let me check over here. Because it should be, maybe you can try to Google. It is not a correct answer for this. For 7 over here, you can see negative 7. 7 will be 1, 1, 1, and then you just add 0 in front to complete the 4 bits. And because it's negative, you change for first complement, you will get 0, 0, 0, 1. And second complement, you just add 1, you will get 1, 1, 1, 1, 0, 0, 1. First why? The answer should be 1, 1. Did I do right? 0, 0, 0, 1. When we convert, will be 1, 1, 1, 0. Correct lah.
Yes.
Just now I do what? This is 1. And then we convert to first complement, it will be 1, 1, 1, 0. And then we add with 1. Then that's why it's get 1, 1, 1, 1. Just now what I did, the value here.
Doktor salah tulis tadi.
Kira?
Yes.
Saya buat apa?
Doctor just flip the number.
First
1000.
1, 0. No. Oh. Okay, sorry. Supposedly, 1 here, we change it to be 1, 0, 1, 1, 1, and then we add here with second complement with 1, and then we get 1, 1, 1, 1. Correct lah. Yo, 2 times I did. Okay, it's totally because of age. Bagi alasan tu. Okay, then this is how basically you get the second complement from your first complement. See, when I get wrong for my first complement just now, I will get totally wrong for my second complement. So please make sure carefully know about our first complement. Don't confuse with positive number, and don't confuse with this charge thing. If it is negative, don't remember anymore about the 0 or 1 sign. You just apply, if it is negative, you just apply this conversion, 0 to be 1, 1 to be 0. This one is example for first complement, second complement. Okay, for second complement, the similar example. Let we see for 25 positive. I don't want to look because it's totally similar. 25, 1, 1, 0, 0, 1. This is my 25 because it is 8-bit. I need to put 0, 0, 0. This is 8-bit, negative in front. Because it is negative, I change it to be first complement first. 0, 1, 1. Correct me if I wrong again. I just change 0 to be 1, 1 to be 0. And second complement, I need to add with 1. So my answer will be, this is my second complement equivalent to negative 25. Let me see in a proper way. You can see over here. This is your answer, or it is not showing you the method. But it's direct change, you can see. You apply 0 to be 1, 1 to be 0. And your first complement, you just add with 1. That's why you will get this number for second complement. Example here, compute blah, 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 7. So over here, it is also similar, negative 23, 23, 16, 0. Tolong convert. 16 tambah 4 tambah 2 tambah 1. Betul ke? Tambah 4.
Betul.
Okay, this is 23. And then because it's not need to be 7, 1, 2, 3, 4, 5, 6, 7. So it's going to be like this for 7 bit and you have negative in front. Kenapa saya tak tengok? Sini dah ada dah. Saya nak kena fikir lagi. Aduh. Then for first complement, you just change it to be 0, 0, 0, 1, 0, 1, 1. This is your first complement. And if let's say you want to have second complement, so second complement, you just add with 1, you get 1, 0, 0, 1, 0, 1, 1. So this is second complement. So this is your answer. As simple as that. And you can try also, there is exercise for you to try, play around and check the answer. This one is summarization. You can see there is a sign magnitude method, first complement method, second complement, but for positives, it is always similar. But for sign number, you need to see carefully. Jangan confuse with the sign in front. Because the totally when you apply for second complement, you're not going to like add 1, but it's automatic will get 1 because of the method that you convert from 0 to 1, 1 to 0. Not because you put like this sign magnitude, you direct put, right? But this one, you are not the one that put. Instead, you change the value. So now, as mentioned, why we need to learn adding, which is why we need to learn first complement, second complement, because we want to play around with additions and after this subtraction. Our table, you can see this table I already show you before this. 0 plus 0, you will get 0. 0 plus 1, you will get 1. 1 plus 0, you will get 1. 1 plus 1, you will get 0 as a sum, 1 as carry. 1 plus 1 plus 1, you will get 1 as a sum, as a carry, 1 as a sum. Sum and carry. This is the table for additions. Let's take a look over here. Example. You have 0 plus 0, you get 0. 1 plus 0, you get 1. 0 plus 1, you get 1. 0 plus 1, you get 1. So easy. There is another one, which is when you apply carry. 0 plus 0, you get 0. 1 plus 0, you get 1. 1 plus 1, you will get 1 carry, sum as 0. Sum 0, 1 carry. 1 plus 0, you will get 1. And then 1 plus 1, you will get 0 as a sum, carry as a 1. 1 plus 1, you will get 1, 0. And then you get plus with also 0, you will get 0 as a sum, 1 as a carry. So this is just like a normal mathematical darjah 1. Standard 1. So example here, you can see using 8 bits second complement represent the following operations. When you have this value, you can see this value for positive things. When you try to add, you can see you try to add this value will be positive 1 to 7. Add bits. This one is our sign. This is our magnitude. This is our sign. This is our magnitude. If you add it directly, you get result wrong because it is negative number. And I don't know whether the value here is similar or not, but the result is wrong. You can calculate it by yourself. This is why I mentioned sometimes you will get also wrong. Just playing around with binary things, you can get like a wrong answer. Again, You can see over here, when you have use 8-bit second complement represent the following. You want to add 60 with negative 30. Negative 30, when you use second complement, you will get 1011. Okay, this is the answer. Try to calculate it. And then you will get this value. This value you will add with this. What will happen? This is positive 60. This is negative 30 for second complement. And this is your answer, which is positive 30. The carry will be ignored and discharged because you only have 8 bits. This is how you adding to positive and negative number using a binary, but using second complement. You can see over here, you will get the correct answer when you play around with negative sign. You can see? Where is it? Okay, here. You will get the correct answer. Just need to discharge or ignore the carry. And for the plus over here, you will get the result as a wrong because this is like a positive number. Positive number, when you like adding using a second complement, basically it is like a sign and a sign, but you will get a wrong if you apply a sign. But the value, I think, calculate the value here, what you will get, including the 1 here. 11001001. In decimal is what? You don't have calculator. Ayo, lambatnya.
201.
201. So supposedly it's correct, right? 127 tambah 74, 201. Betul. So you can see if you apply the magnitude and also sign, you're going to get a wrong because you assume this to be negative. But when you apply in term of normal adding, without for you to mentions whether it is negative or positive, because it is positive number you add, you will get this correct value, isn't it? Which is 201, which is similar. Only that when you apply in term of like first complement or sign or magnitude, you will like get a wrong because of you assume this to be negative. Correct, right? The answer. Okay, so what is the purpose for second complement? First complement is always for the negative part, negative number. That's why when you add negative number using the second complement, your answer is correct. The one that I show you, which is positive 7 and negative 5, when you add, you're going to get wrong answer just because you directly convert, let's say 111, and then you have 1101. This is negative 5, this is positive 7. When you add, you get the totally different answer just because your method is wrong. You cannot apply the sign magnitude for negative, then you will get error. That's why you need to learn second complement for the addition. Okay or not? Is there any question related to why you need to learn the first complement, second complement, where you can apply? If no, you can see you can also apply the second complement for subtraction. For subtraction, you can see similar to your additions, you can see carry from MSB sign is deleted. You have example. This is only for MSB, which is the one. Example here you have, dia tak bagi directly the integer number. So it's going to give you the binary, not decimal. So you directly convert here. You can see this is your negative. You can see when it's negative, we normally will assume it as a negative number. What happened? Let's say I have 7 minus 5 equal to what? So over here, what I can do is 7 plus negative 5. It is similar. If let's say I have 8 minus 9 equal to whatever, then you have 8 plus negative 9. This is similar, isn't it? That's why in our binary, we will do and apply this thing. If you have this kind of subtraction, we will change it to be adding also. Because it is very hard for you to do negative, which is on the binary number. That's why we will adding. So we will assume the next number to be negative. So like this, we will assume it to be 0, 1, 0, 0, 1, 1 plus negative 0, 0, 1, 1, 1, 1. So we try to convert this. This one, the value is, I don't know what is the value, but when we apply first conversions or first complement, this is negative number. Our first complement will be 1, 1, 0, 0, 0, 0. And second complement, it will be 1, 1, 0, 0, 0, 1. We add 1 only. And when we have this part, second complement, then we can add directly. We cannot deduct or subtract negative number until we have the second complement. So this is our second complement. We can add it 1, 1, 0, 0, 0, 1. So this part we will ignore, which is our MSB. So this is our answer. So let's take a look. Dia tak bagi dalam nombor bulat. So this is the example over here. You just ignore the MSB part, the carry. So the one that you answer, maybe you try to convert in decimal. Decimal ni berapa? 8, 6, 16, 19
Betul?
tambah negatif 8, 12, 15. Then you will get your answer supposedly positive 4. It is correct. You can see over here you have positive 4 in binary. So that's why you can like adding, subtracting using the second complement without error for negative number. Okay, perform the operation below using 6 bits complement. Second complement for 6 bit. Okay, you have 24. 16. Berapa? 24 convert to binary. 16 tambah 8.
1 je.
And then you have, this is for your 24. And then you have 8, negative 11, 0, 1. Ada kosong lagi 1 eh? This one is 8. 4, 2, 1. Ada lagi 1 kosong eh?
Dia kata kosong.
You have another 0 here. And this one is correct, right? 1, 0, 0, 0, 1 for 17. And after that, you need to add here. This one is remain like this. And this you need to change to first complement. You will get, and your second complement, you will get 0, 1, 1, 1, 1. So what happened? We will add. Oh, sorry, I forgot the in front. You can see 1, 2, 3, 4, 5, 6. 0, 0, 1, 1, 0, 0, 0. Correct me if I put a mistake to the conversion. Plus 1, 0, 1, 1, 1. Tak cukup. Betul lah. Kejap. 0, 1, 1, 1. Then you all ni tak membantu I langsung lah.
Doktor buat yang untuk 24 tu 7 bits.
7 bit. Oh, okay. 24 apa? 1, 1, 0, 0, 0. Ni eh?
Ya, doktor.
3, 4, 5, 6. And then 17, 0, 1, 0, 0, 0. Ada lagi 1 0 ke? Tak kan? Betul ke tak?
Betul, doktor.
And then I change it to B. Saya tak ada calculator Saya guna otak saya yang slow ni. So this is our first complement. My second complement will be 0, 1, 1, 1, 1. So I add here 4. So I ignore this part. This is my answer. This one is 4, 2, 1, 7. 4, 2, 1. Betul kan? 24
Betul.
tolak 7. Kita dapat berapa?
17 doktor. 24 tolak 17. Dapat 7.
Dapat 7. So you can see in the decimal we will get 7. And then in binary we will get 0, 0, 0, 1, 1, 1. Which is also, if we convert to decimal, we will get 7. So it's correct. That is why, again, you need to do the first complement for negative number. So let's take a look. Mana dia punya ni? Okay. You can see you have positive in front here. You will do the negative 17. So negative 17, first you will get this as a 17. And then because this is negative, you apply the first complement first. And then your first complement, you will add with 1 to get the second complement. Then you direct add these two value. Then you get the correct answer. There is another example. Then you can try to do it. Similar things. And that's all. That is for your module 2. So any question?
No, so far so good.
So far so good. Kejap Penat dah saya direct tak berhenti dari tadi. So because we already finished with our module 2, next week we're going to do with our module lab first. We will play around with the simulator and then we go directly to module 3. Now I'm going to pick Muhammad Rizwan. Share me your screen.
Yes.
Share me your screen and then teach us how to saya bagi soalan lah. You share your screen dulu. You nak buka pen ke, you nak buka words ke?
Okay.
Okay. Now dah share belum? Belum lagi.
E-learning ke, Doktor?
Tak kisah you nak buka apa, sebab saya nak bagi you soalan, you tulis lah. You nak buka dekat pen ke, you nak buka dekat words ke? Masa saya mengajar dah habis lah. So saya nak orang lain tolong ajar. Saya jadi student
Okay, Doktor. Soalan?
Soalan tunjuklah dulu.
Saya pakai buku, Doktor. So, saya tulis ya.
Macam mana you nak ajar kita orang?
Tak apa. Sekejap.
Nanti you tunjuk buku you Okay, tulis soalan 125 tolak 79.
Okay.
Buat dalam second complement 8 bit. 8 ke?
8 bit.
8 bit
Baik.
second complement. Okay.
Itu saja ke?
Itu je cikgu. Cikgu ajar kita orang
Saya student, cikgu.
Jemputan hadiri kursus pimpinan. Saya ada kursus ke depan ni? Ajar tau. Saya bukan nak jawapan.
Boleh. Sekejap. Saya cuba nak solve and then saya teaching lah. Baru senang sikit nak faham.
Okay. Saya makan roti cikgu.
Silakan.
Habis roti dah ni. Tak siap lagi.
Baru siap. Okay, sekejap lah. Doktor, share window ke entire screen? Window.
Tak kisah.
Okay, sekejap. Boleh nampak ke?
Belum. Yang
Ah.
lain nanti prepare ya. Saya ada lagi satu soalan. Lambat lagi.
Boleh nampak ke doktor?
Tak nampak.
Tak nampak.
Yang lain ada nampak ke?
Tak nampak.
Sekejap. Window. Alright, nampak ke?
Okay.
Alright. So first 125 dengan 79 ni dalam bentuk desi kan. So kita kena convert kepada binary dulu. Ini bila convert untuk 125 dapatlah 111101. And then untuk 79 pula 1001111. Tapi nak dalam bentuk 8 bit. So untuk 125 kita tambah kosong kat depan. And then untuk 79 pun kita tambah kosong kat depan. And then lepas tu untuk negatif kita kena buat satu significant dulu. Bila convert satu significant kita akan dapat 10110000. And then untuk dua significant yang kedua cuma tambah 1 akan dapat 10110001. And then yang positif tu kita bawa turun saja. Kita tambah di mana bila kita tambahkan 011101 dengan 10110001 tu jawapan akhir kita akan dapat 11011110 sebab kita ignore carry. And then itulah jawapan terakhir saya.
Yang lain dapat sama ke?
Ke nak convert lagi pi desi?
Convert tengok.
Sekejap ya.
Yang lain dapat sama ke? Kenapa macam besar value ni?
Tak sama.
Tak sama.
Macam besar value-nya.
Tersilap kat mana?
Silap kat mana ni? Yang lain?
You tambah 3 kali 1 kan?
Untuk mana satu?
Yang ketiga tu. 111. You kan tambah 1. Lepas tu 1 dapat kosong, you tambah lagi 1.
Sini kat mana? Sini ke ataupun dekat dekat sini ke?
Yang
Kira akhir tu, yang last.
kira akhir tu.
Kiraan terakhir ni.
You ada salah.
Ada salah kira tu.
Macam tu kena correct bacaan balik
Paling depan tu. Yang sebelah saya itu Rizwan. Kamu satu tambah satu kan?
Betul.
Yang ni. Dia satu tambah satu. Dia sun zero.
1 tambah 1 berapa? Kosong. Kosong. And then 1 pergi depan tu sajalah. Sorry, careless mistake. Apa jawapan akhir dia?
Apa?
Saya risau saya salah.
Risau pula. Aduh. Yuk.
46 betul ya 46. Saya stop presenting ke?
Okay. Terima kasih Rizwan.
Terima kasih. Sorry, salah, careless mistake.
Ajar kami semua. Saya nak satu je orang lagi. Sorry lah, drag sikit masa je, satu je lagi. Tadi saya dah jumpa dah siapa yang saya nak tanya tadi. Mana pergi orangnya? Macam dah terkeluar pula. Chun Taek Yo. I give you a question.
Wait, I forgot. What's the question?
Can you convert 1 0 1 0 1 1 0 1 0 1 1 1 0? Dapat tak salin? Ke ini yang salah? Sekejap saya type lah, saya type.
Okay.
1 0 1 0 1 1 0 1. Okay. Convert this is binary number. Convert to gray code.
Give me a second.
Although kita baru belajar semalam, but what I need you to do is belajar terus ingat method. Macam tu lah. Nanti tiba-tiba nak exam baru nak cari method kat mana. Ini khusus kepimpinan akademik legal. Ni mau habis.
Total.
Yes.
Question.
Can you just share your screen and then you teach us?
Okay. So something like that. So this one, this highlighted one is the binary number we just had. Then we want to convert this number to the grid code. We take the most significant number to the next one and never change the number. Then for the next one, we just take this one to sum out the next number in the binary code, 1 plus 0. So it will become the 1. Then,
I think your method, is it correct?
or is something.
Everyone, is it correct, the method?
I think you don't need to add zigzag. You just add the binary line, like 1 plus 0, 0 plus 1, 1 plus 0.
Yeah, the zigzag method is supposedly gray to binary. If binary to gray code, you need to add the binary only. One plus 0 will be 1. Then your answer for your gray code also is wrong.
What place is one? Something. Then this one is sum out to this one equal to 1. Then 1 plus 1 equal to 0. 0 plus 0.
No. Your method now you are using the zigzag, which is method gray to binary. But the question is binary to gray code, which is you need to add first 1 plus 0 and then 0 plus 1, you just add the binary number, not the gray code.
Just need.
You add that one with
I
beside. Add left to the right, left to the right, left to the right. You add that number only.
okay, let's see. So
Mama nak kerja ambil komputer dia kena sedikit.
so this one 0 plus 1 equal to 1, right?
Yes.
Then
And this part is supposedly 0 plus 1
oh, I mean
because
so it's
the beside binary is 0, 0 plus 1 and then 1 plus 0. Okay. Another one.
another one.
Number 1, 2, 3, 4.
1, 2. This one.
1.
Okay. Oh, sorry.
Okay, so this is the answer. So you can see that yesterday we already learned, I guess yesterday, right? We already learned how to convert binary to gray code to binary. So I hope that you also will know which method that you need to apply. Okay. So thank you, Theo. Take Yo for teaching us. I guess I already I spent until 15 minutes for you. Sorry for that. And I'm going to share another one more time the class attendant. For those who already scanned, you can leave. So thank you and please stay at home and goodbye.
Stay safe.
Stay
Thank you,
safe.
doctor.
Thank you, doctor.
Okay,
Thank you,
thank you,
Doctor.
doctor.
Okay, bye-bye.
Thank you, Doctor.
Stay
Thank
safe.
you, doctor.
Doctor.
Thank you, doctor.
Thank you, doctor. Bye-bye.
Okay.
Mama je.
Dah keluar dah semua.
Semua orang ada scan.
Tapi mama record.